All right, so 1.4. So 1.4, we're going to talk about set operations, sets of things. And what we're going to really want to get to is Venn diagrams. Our Venn diagrams is sort of the meat of this section. Before we get to Venns, which are a physical representation or a visual representation of collections of objects, all right, which then we use them in later sections for different things. All right, so a set, right, when we say set in mathematics, or actually in anywhere, what it just means is a collection of objects. All right, so again, the real numbers is the set of all real number values. The odd numbers is the set of all odd number values. The set of math majors at the university, right, that'd be a set. The number of ways heads or tails can pop up, that would be a set. Right, so again, it's just a collection of objects that you've put aside. All right, so 2 examples of set here. I have set S, or the numbers 1, 2, 3, 4, and 5. So it's just the set of the numbers 1 through 5. Set T are the colors, red, white, and blue. Right, and so those are 2 examples of sets. All right, so given a set A and set B, we then use the term subset. All right, subset means that A is a subset of B if and only if every element of A is contained within B. And so if you were to draw a Venn diagram for that, basically you would have circle A would be my set A. So again, when we do Venns, circles typically represent sets and subsets. B, sorry. All right, so it would be something like this. Set A is contained within set B. Every element of A is also an element of B. That's another way to word it. So if set B is the numbers 1, 2, 6, 8, and 10, set A is the numbers 2, 6, 8, A is a subset of B. If you were to draw the Venn diagram to go that, well, circle A would have the numbers 2, 6, 8, which would be in, so that would be set A, which would be in set B, because set B has 2, 6, 8, but set B also has more. It has the numbers 1 and 10 as well. Make sure you have them all right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so A is a subset of B. All right. And again, the subset notation that we use is sort of a sideways use. And little bar means technically a subset could also mean the sets are equal. Right. That's what this means. A little bar means there could be equality. All right. A could be the same as B. Right. I could have set C that is the numbers 6, 8, and 2. Which means circle A is in circle C, all right, because 2, 6, and 8 are in both, right? So that's where you can have equality. All right, a proper subset, if every element of A is contained within B, so there's the set, and at least one element of B is not in set A. So meaning set B is bigger than set A. There is no equality. That's what that means. So it's more like my first example up here. All right, so set A is a proper subset of B. Set C is not a proper subset of A. But set A is a proper subset of B. Every element of A is in B, and B has more elements in it. B is the bigger set. All right, so A fits within circle B, and B still has some elements on the outside that aren't contained in A. All right, suppose that we have the following sets. Set A is A, E, I, O, U, the vowels without Y. B is the entire alphabet, A, B, C, D, E, all the way to Z. All right, so the first question is A a subset of B? Are all of the elements in A contained in B? And the answer to that is yes. Yes, A is a subset of B. Is A proper subset of B? Yes. A is a proper subset of B, because if I were to draw the circles, the vowels fit within. So basically you would have circle B, which would be the entire alphabet, and then circle A would be the vowels, and then everything outside of A would be consonants, right? And so it would contain and fall in the definition of a proper subset. The last one is well, can I flip it around? If A was a subset of B, can B be a subset of A? If they were the same size, that would be true. like my example A and C up here. A is a subset of C, and C is a subset of A. Because of the equality, you can do that, but only if they're equal sets. If they're not equal sets, that's not true. And so B is not a subset of A, right? Every element of B does not show up in A. You can't take circle A and fit circle B into it, all right? Doesn't work that way. B's on the outside, all right? And so that does not work, all right? So it is not. So this is no to the last one. All right, if we're given two sets and we want to combine them, there's two ways you can combine sets. You can combine sets by using the word and. You can combine sets by using the word or. All right, so given set A and set B, we find a new set, and it would be an entirely new set with different numbers in it, that represents A and B, meaning all the elements that are in both A and B. The symbol that we use for that is N, although typically in this class we will use the word A and B. But if you see this A and that symbol stands for and, A and B. And so if I go back to my example that I had earlier, my A, I remember what it was, 2, 6, 8 were the number in A, and then B was the numbers 1, 2, 6, 8, and 10. I want my new set, we'll say C, we'll call it set C, to be the elements that are from A and B. And so I can only pick the elements that are shared by both. And so if I look at my B, they share the numbers 2, 6, and 8. All right, so the numbers 2, 6, and 8. So set C would be the numbers 2, 6, and 8. Oh, well, what if I picked a different set? Instead of the set A, which is a subset of B, let me pick a different set. All right, suppose set A was the set A, B, C. And set B was the set B, F, G, and H. All right, so A is A, B, C, B is B, F, G, H. And I want A and B, and I'm going to again call it the new set C. Again, it's their overlap. It's what they share. So in this case, the only thing between A and B, sorry, not A, the only thing between set A and set B is the letter B, right? That's the only thing they share, and so that's it. C would just contain the one letter, B. All right, well, what if they didn't share anything in common? Well, if they didn't share anything in common, we call those disjoint sets. So if set A didn't have B in it, just had A and C, in that case, we'd say they're disjoint. That means they share nothing in common, no elements in common. Right, that's sort of a special case. All right, most of our examples, they'll be overlap. That was just sort of an FYI for your information. All right, the last one on this page, all right, so that's the and symbol. And means they have to have elements from both sets, so they have to share the elements. Then the other way you can combine sets is using the word or. What's nice about or is all-inclusive. And again, it's sort of a use symbol that's used. So given set A and set B, we have a new set when we combine set A or set B, or both. So it's everything. So it's everything from set A with everything from set B, and even the elements that they share in common. The biggest thing with the elements they share in common, you only write them down once. All right, so if A was the letters A, B, C, and B was the set B, F, G, H, and I want everything from A or B, and again, the symbol for that is sort of an upside down U. We'll call that new set C. Well, it's basically all-inclusive. Everything from A gets included, and everything in B gets included. I include the same thing that they share. They share the letter B, but I only put it in one time. There's only one letter B in the alphabet. And so when I put it in my set, I only put it in there one time. So my set A or B would be A, B, C, and then everything from B, not including the B again, so F, G, and H, and then I'd sort of double check to make sure I have them all. A, B, C, I have B, F, G, H, so it checks. So there's the set that basically, so again, the OR is all inclusive. I get to include everybody, but I only include everybody one time. So even the one they share, I only include it once. Alright, so a couple more examples. Given that set A is a larger subset of set S, then a new set A, then a new set not A, is the set of all elements that are not in set A, but are still within the larger set S. Alright, so this would be what we call the complement. Alright, the complement. We're not in set A, but we are in set S. So suppose set S was the alphabet. A, B, C. Let's not do the alphabet. It's too big. Let's just do part of the alphabet. A, B, C, D, E, F, G, H, I. Alright. Set A was the letters B, C, F, and I. Alright. A is a subset of S. Alright. All of the letters in A are in S. S is the bigger group, right? So S is the bigger group. And we want all of those that are not in set A, all right? So anything from set S that's not in set A, that's what we want, all right? So basically you go through set S and you pick those out and make sure that they're not. So if you wanted to, I guess you could kind of go through and highlight the ones I don't want from S. So A has B, so I don't want B. A has C, I don't want C. A has F, I don't want F. And A has I don't want I. Alright, because those show up in A. So all of the letters that are not highlighted are the letters from set S that are not in set A. And so we pick A, E, G, and H. Those are all of the group's letters that are not an A, but still a part of my larger set. So if we were to draw the Venn diagram, suppose my set S was the rectangle, my set A was the circle. A would be the letters B, C, F, and I. Those are all in A. All of the ones not in A would be outside the circle. E, A, G, and H. Right? Those would all be not. Right? And so everybody not in circle A. All right, that's sort of how the Venn diagram would work. All right, let's do another example. All right, given set S is the numbers 1, 2, 3, 4, all the way through 20. So even though the ... there, that indicates numbers 1 through 20. All right, so 1, 2, 3, 4, 5, 6, 7, all the way up to 20. Subset A is the numbers 1, 2, 3, 4, 8, and 12. B is 5, 10, 15, 20. And C is the set that's given there. All of them are subsets. All right. A is a subset of S, B is a subset of S, and C is a subset of S. All right. All of the numbers given are between 1 and 20. All right. So the first group I want to find is everything between A and C. So that's the A and C. So it's a new set, A and C. So I look at set A and see what they share in common with set C. So first of all, I start with a smaller set because it's just easier. 1 is in C, so I include it. 2 is not in C, so I don't include it. 4 is not in C, don't include it. 8 is in C, so I do include it. 12 is in C. So again, the numbers 1, 8, and 12 are in both groups A and C. And so that's my new group, where my numbers come from A and C. All right, the next one, B and C. So I want to pick everything that's in B and at the same time in C. All right, so again, I'm going to start with B because it's easier to start with the set that's smaller and kind of look and see if that number is included in C, I put it in the AND group. All right, 5 is in B, 5 is in C, so I include 5. 10 is not in C, so it's not included. 15 is in C, so I do include it. And then 20 is not, so I don't include it. So the only two numbers they share are 5 and 15, and so that's the only set. Those are the only two numbers in the set B and C, 15 and 5. All right. And just sort of a rule of thumb, and should always be a smaller group than what you start with. And then or will be the bigger group because or gets to be all inclusive. All right, so I get to include everybody when I do the or statement. All right, so the or, everybody from C or A. And so I kind of walk through it and I try to do it in order since they're numbers. All right, so I start with A. 1 is included because 1 is in A. 2 is in A. 3 is in C, so I get to include it. 4 is in A, I get to include it. 5 is in C, so I include it. 6, there's no 6, so in A, and no 6 in C, so don't include it. 7, there's no 7 in A, no 7 in C, so don't include it. 8 is in both, so I include it. 9, no 9 in either. 10, no 10 in either. There is an 11 in C, so I include it. 12 in both. No 13, no 14, 15 is in C. 17 is in C, no 16, 18, and then 19, because again, I know I don't have to look at A anymore, because A only goes up to 12. And so those are all the numbers that are in A or C. Again, or is all inclusive. I get to include everybody. You can kind of double check and make sure I have it. 1, 2, 4, 8, 12 comes from A. 1, 3, 5, 8, 11, 12, 15, 17, 18, 19 is in C, so I'm good. I included everybody from both groups. All right, the last one, not C, which means from set S, which are the numbers 1 through 20. So I can pick any number 1 through 20 that is not in group C. So again, I'm looking at group C, and basically I'm going to do a count. 1 is, so I don't include 1. 2 is not, so I include 2. 3 is, 4 is not. 5 is, 6 is not, 7 is not, 8 is, 9 is not, 10 is not, 11 is, 12 is, 13 is not, 14 is not, 15 is, 16 is not, 17 is, 18 is, 19 is, 20 is not. And then again, I make sure when you count both C and not C, it should equal my S set. So if I go through C, 1, 2, so I kind of go back and forth between the two. 1 is in C, 2 is not, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So all of the numbers are included, so I didn't forget anybody. That's the biggest thing, is just not to forget anybody. All right, so there is everybody not in C. All right, and then finishes up. So the next thing we're going to look at is actual Venn diagrams and how they how the setup for Venn diagrams are. So that was sort of an introduction to sets and using the terms ands and ors. All right, so we'll stop there and I'll pick up the next set of notes in the next video.